that they're working. I had to re-upload it.
It got 6 in the morning.
All right. What?
And Albert Lee's is just to wake up at like 4.
All right.
I have a question real quick.
Stay.
Can I get through this first? I don't have a lot of time. All right.
Yeah, we still Darla sheet.
Okay. I had a lot of questions yesterday on problem number 1 and 2. They're based on inverses. So the goal today is to do a couple examples of inverse functions so that you know exactly what type of problem I could put on the test. Okay, so let's walk through 2. I'm going to walk through an easy one, kind of one that's more practical, hint, and then maybe if you need another one, I can do a third one as well. But I have 2 that I want to go through to make sure that it makes sense, so you can double check the answer. There's 2 ways to do this problem. Okay, so again, this would be based on the first 2, even though these are not the answers for the first 2. Okay, Drowsy, go sit. You're right. Great. All right. So here's my function to start with. All right, 3x plus 1. All right. So let's say that this is my function, and the whole goal in that first question, maybe it says in the directions, is find the derivative of the inverse function. That's what it wants. So it wants this. It wants the derivative of the inverse function. That thing. That's what it wants. Derivative of the inverse. Okay, there's 2 ways they could write it. I know that a lot of people like the ddx thing. You can write it like this. I've seen that before. That just is, to me, it's kind of goofy looking. They have the -1, then they do the little prime symbol on it. There's 2 ways to do this problem, but the shortcut that is supposed to be there for more difficult problems is this. To find the derivative of the inverse, right? The derivative of the inverse. This is the formula that the book has. It's 1 over the original function, but you take the derivative of the original function, and then you plug in the inverse into it. And I think we talked about that yesterday. Now, how I want to show you how this works, in case you didn't like the problem 1 and 2. We're going to do it for this problem just so you can see this. So there's 2 ways to do this problem. One is kind of easy, one's more difficult, and I want to just show you what we're doing here. All right, so first, doing this 3x plus 1. Let's go and find the inverse first. So this is how you find an inverse function. Because why I'm doing this first is I do have to plug it in. So I'm going to do that shortcut. So the inverse function, you switch the x and y around, if you remember us doing this. We switch the x and y around. You solve for y again. So I'm going to subtract the 1 across, and then divide by the 3. Okay, what you're looking at here is the inverse. So this is the inverse of the original problem with x's as your variable. Does that make sense?
Yes.
Okay, now what we're doing is we have to find the derivative.
Wait, that's
So-
so easy though. Okay.
Okay, yeah, and that's like this is the easy problem. So you can just take the derivative of this and you're done. Or you could do that formula. So we're going to do both so you can see that they give us the same answer. Does that make sense? Okay, are we good so far?
Yes.
Yes.
All right, let's go through and let's do what the actual formula says to do. Okay, and then we'll talk about how to find this thing. Okay, okay. Does everyone understand the first derivative? Or sorry, the inverse. How to find it?
Yeah.
Okay. Again, this may not be possible with a really difficult looking problem. That it will be really complicated because you have to solve for y, and there might be a lot of y's so you have to factor
Here, wait,
in
don't
y.
erase that yet. I need to get my glasses on.
Yeah, where are your glasses? Can you not see?
Mr. Ward.
I took a shower this morning. I don't know where I put them down.
Your
So
If you had to guess on the test, would you say it would be a problem like that,
I like
or a
these
problem
better.
that's more challenging?
I would say something like that, but I'd probably maybe put it like an x squared.
I don't like how you choose it.
Does that make it any harder or no?
Yes, it does. And then you have to do square root.
Or was this the one where there might be a table?
You'll see it one.
Which one might there be a table in?
That'd be the second type.
Why do you change X and Y?
That's how you find inverse. You're just doing the opposite operations. That's what it does. Because when you resolve, it does the complete inverse. Instead of adding 1 and multiplying by 3, they subtracted 1 and divided by 3. It's literally an inverse. It's everything opposite from the original.
Got it.
Okay, all right. So let's do the first derivative. So what the formula says to do is we do this. It's going to be 1 over, and we're going to have to find the original derivative on the original function. And if there's any x's left, you plug the inverse into it. The inverse that you found. That's the shortcut for a really complicated problem. So let's talk about how do we find the derivative of this thing, the original problem.
3.
Power
Okay,
rule.
so yeah, it's just 3. You know, it's the power rule. It dropped the 1 out front. You subtract 1 off the x goes away, the 0 is for the 1. So the derivative is literally 3. So I'm going to put it down here. Okay, it goes on the bottom. All right, now, since we put the 3 on the bottom, is there any x down there that I can plug my inverse into it?
No.
Like, the derivative is just 3, right? There's no x's. So that's the answer.
1/3?
It's 1/3. That's literally the derivative of the inverse, because I can't plug the inverse into it. So if there was x's here, if there was x's back here, I would take out the x's and plug this inverse we just found into it. I don't have any x's. It was literally just a 3, so that goes on the bottom. That's what this is saying. That's the answer. Well, Jossie was even talking about this. Like, this is the inverse, right? We found it earlier.
Yeah.
Taking the derivative of this thing is really simple.
1/3,
It's just 1/3.
obviously.
So, because this thing, we can change this problem so it's kind of easier looking. If you don't like the 1, you know, the 3 on the bottom, you can change this to be 1/3 out front. And when you take the derivative of it, you ignore the number, but you take the derivative of the inside basically, and the derivative of x is just 1, and the derivative of -1 is 0. So this would be 1 times the 1/3 out front. So it's literally just 1/3. So taking the derivative of an inverse is the same as doing this little shortcut formula thing that they gave you. They give you the same number. So if you want to go through this process, like, because this is the question you asked, like, why do we have to do this? This will get you to the inverse, and then you can just take the derivative of it if you want to, or you can do the shortcut for a really complicated problem. That's the shortcut. Take the derivative, you plug the inverse into it, and you're done. Because maybe this problem is like, this thing, the inverse that you found, is so complicated, I do not want to find the derivative of it. You can just do that formula where you do the derivative of the original thing, which was easier looking, and then just plug this inverse into it, into little spots. So there's 2 ways to look at that problem. So I'm giving you 2 outs in case you don't like one of them.
So if your 3 had, like,
Giving love.
it was longer than that.
Yeah, let's say it's 3x, and like there's other numbers. You would just take out the
And you
x's,
put that.
and you just plug this into those x's, and you're done. You just move on to the next one. You don't have to simplify it or
Probably
anything.
wasn't even football.
Okay? It's just, I want to give you 2 ways to do it. So you could either just find the inverse the old-fashioned way and just take the derivative of it right away, or you can do the shortcut, which works for really big, complicated things. It's like it's actually an easier process, but it still requires you to go find an inverse.
The inverse
So.
of E is ln and ln is E.
Yeah. So that's what we were talking about yesterday. That's why I went to the bottom. So. All right. Now let's talk about the one that Dalton, you were asking me about earlier. Because you asked this morning about inverses because this is what your question was based on. The book had a different style problem, which I think is probably the best type of problem that I might put there, which is kind of an easier step. Hint, hint.
What's it?
So,
What he's about to do.
He's gonna show some magic trick.
You know what he's gonna actually
Magic
do?
turkey.
What, Josh? What is he gonna do?
He's gonna have a walkout.
He's gonna organize a walkout for
Okay.
college students.
Right now, right now, right now.
I'll do it. I'll participate. Put water and some sugar out of it.
Start banging on down. So walkout. What was it? The movie?
Yeah. Spanish. Springing on the lockers. Walk out! And you get like
I remember we had a walkout last year. We're saying 3 students.
I remember that. I was one of those students.
No, you weren't.
Yeah, I actually was.
Were you?
No.
I was gonna say I didn't think so because if you 2 both did, then there was like 4
Five.
students.
And what was the lockout for?
Walkout.
For the Florida shooting.
The Florida shooting.
Portland.
Were you gonna say Harlem?
There's a lot of shootings.
okay.
Where's Harlem?
All right. We ready to go here?
Yeah.
All right. So here's the idea. They want us to find the inverse derivative. So they want us to find this d of the inverse. So the derivative of the inverse with respect to x. And this is what they give us. They give us that they want us to find the derivative, and they want us to do this. Find the derivative. Oh, geez, I wrote that terribly.
I'm so sorry.
All right. So the derivative of the inverse, and they want us to find it
Wait.
for like the number 3.
You-
Oh, we did this a
The
long time
inverse of the
ago.
inverse or the
You put 2
derivative?
negatives.
Yeah. What?
2 negative ones.
I thought he was gonna really guess what's
I was so scared. And I was like, I don't understand what
The
that
All right,
inverse
all
of
right.
the-
So, all right.
The
So
original.
we're finding the derivative of the inverse, but we want to evaluate it at the number 3. So if they give you a table,
Just switch next.
Here's the best way to do it. You have to use the shortcut. Use the shortcut, and this is what you do. You go 1 over the actual function, the derivative of the original function, and then you're going to plug the inverse right here. And in our case, we have a 3 sitting there, right?
Yep.
So that's what we're doing. Now, all we have to do is think about this logically. What an inverse is, so I'm just evaluating this thing. An inverse of 3. The inverse is going, if my answer is 3 here, it's going back to what the original x should have been. So what was the original x that gave me 3? 1. So this number is a 1 sitting there. Does that make sense? This whole thing is 1.
That is 1?
Okay, because
wait,
the inverse, that's not my final answer. This part that's inside that parenthesis, f of -1 of 3.
1/4 is your
is-
answer.
Okay, yep. And we're going to go back to the original x that gave me the 3. That's what this is asking you to do. So this number becomes a 1 here. So the f -1 of 3 is 1. And then, if you didn't hear Sid, she actually said it right. The derivative of 1,
Surprisingly.
so the derivative of 1 is that number. It's 4. So this thing on the bottom now became a 4. And so your answer is 1/4.
I thought it was 1/8.
Okay.
You were wrong.
No, because I went to 3 and then I just jumped over.
Alright, questions with the concept of how that works. That's why they use this shortcut. It's for like when you have a bunch of data, you can go back to what the original x should have been, to give you this number, and then you plug it into the derivative and you figure out what that answer should have been. And that's the idea.
Yes, sir.
Okay, do we understand inverses now a little bit?
Relative.
Those are the 2 types of problems I'd probably put for you,
On
1 and 2.
On a scale from 1 to 5, I'd give you a 3.7.
Okay.
3.7.
Alright,
Alright, number 6.
Oh my god, 3.7, that's our
we gotta start number 5, I think, don't we? Or is that the
We
semester?
did 5.
We did 5.
We're number 6.
Unemployment rate.
No, number 7. It skips from 5 to 7. No, it doesn't.
No, we're on number 6. We're on number 6.
Alright, here we go. So that was talking about 1 and 2. We did 3 and 4 yesterday. We did 5. We have to start with 6 and move on. My goal is to get through 10 today really fast. These problems,
You're on the wrong one.
hey, these problems should be based on what we did the last homework assignment. Okay? Alright,
Yeah, we did 5 on this one.
and I have all the formulas on the board over there in case you need them. Okay, I gotta check the surface area for the cone. That one got smudged the other day and I tried to go from memory. I'm gonna have to double check that here in a minute. I wrote that up before class, I just noticed it was smudged off the board.
Wait, we
Alright.
have
Why are we on
to use
eight?
the cone?
Yeah, wait, why do you have it?
We're going back to 6, sorry. Alright, so we gotta find the derivative and the inflection points for this one. Alright,
Who made you that card?
first,
Oh.
derivative of this thing.
Disgusting.
Quotient rule.
It's 1 times x squared plus 1 minus 2x times x over x squared plus 1 squared.
Whoa, go another.
Oh, I know that.
Listen, I had that. Next to me.
What does this say?
That's just the answer?
Okay, hold on. Okay, so first and foremost, that was the derivative of the original thing. We had to do quotient rule, derivative of the top times the bottom, derivative of the bottom times the top, all subtracted, and then over the bottom squared. If we simplify the top, we get x squared plus 1 minus 2x squared, and that's on the top, because I actually multiply that, I'll subtract and stuff here in a minute. On the bottom, I'm not actually going to multiply that together like FOIL, because we'd have to just factor it apart again to figure out the critical points. So I'm just going to leave the bottom alone. On the top, though,
3x squared.
yeah, this turns out to be
What?
it's
Negative.
1 minus 2. So this turns out to be 1 minus x squared on the
I
top.
like the. What?
Can it just be negative x squared plus 1?
Yeah, I'm just writing it like this because I want to have the negative up front. All right, so here's what we have. The top, if I want to figure out the critical points here, I factor the top apart and figure out what makes it 0. That's a critical point. So, how do you factor the top apart? How do you factor this?
1 minus x, 1 plus x.
Good.
Thank you.
All right, so the 2 numbers that would make these
One
both
and
0 on the
negative
top, it'd be 1
I don't like it.
and negative 1. All right, so these,
X squared minus 1, not.
But
It doesn't matter. I mean,
everything's perfect. Please.
Oh, no, it's right.
Just stop confusing me more.
okay.
Alright,
Just right.
got it.
So these are my 2 critical points. Now, we did have some points we'd have to throw out on the bottom, but there's no way that can be 0 on the bottom, so we don't have to worry about it because we're squaring it and it turns positive anyway. All right. Now we have to figure out the second derivative. We're gonna do the second derivative on this little guy.
Oh, that's.
And then we'll have to
Quotient Little guy.
So quotient rule again, so it's a little more
Oh
complicated.
god,
It's gonna
there's
be
a chain rule. God,
-2x.
Cindy, there's a chain rule.
There's not a chain rule.
Yes, there is.
No,
On the
there is.
bottom.
On the
No,
bottom,
that's
yeah,
just
he's
squared.
like, wait, what?
It's just squared, it's not the derivative.
It's chain rule.
It's still a chain rule.
It's a
when
chain
you do
rule.
derivative bottom.
Oh.
So,
Go back on the derivative.
That's gonna be
Oh, wait.
negative 2x.
You do it by the
Negative
inflection
I
point.
have
okay.
a-
Derivative of the top,
I'm
negative
about
2x.
to have a
Times the
Over
bottom.
2x squared, 2 out front, and then x squared plus
No, it's a
1.
heart attack, but I
Oh,
Okay.
wait, what are you
I
doing?
thought you-
That's the derivative of the top times the bottom,
I was like, oh,
right?
What?
Okay, yeah,
Plus, minus the derivative of the bottom.
2, then x squared
Wait.
plus 1 times 2x.
Why do we have to do the whole
Yeah,
thing?
times
Times
on top?
the bottom, oh my goodness, times the
I just
top.
told you the answer.
What is that? 1
Why
minus
did
x
you make
squared.
this
Wait,
problem
is
so
that
hard? You know
2x or
you write
negative
the
2x?
test, right?
So, okay,
Is it times, hey, Mr.
Yeah,
Ward,
why would
But
is
you
it
do
times
this?
2x or times negative 2x?
times
2x.
2x.
Oh,
That's,
Because the x squared plus 1 is 2x.
yeah,
And
so the
that's not
derivative,
last
the
then.
derivative of the bottom is actually 2 out
Wait, why
front,
do you have the?
x squared plus
Oh.
times 2x, because that's the derivative of the inside.
That's 1 negative
Yeah,
x squared.
sorry, it got squished, I'll
minus
simplify here in a minute.
Oh my god,
And
and
then-
it's all over the bottom squared.
It's times, right?
So it's x squared.
If you
plus
put
1.
1 in front of the x squared.
Why are you doing this?
Okay, let's simplify the top a little bit.
Here, wait, hold up.
I don't have any more.
Just give me some time to write it, please.
That's okay.
You have a whole whiteboard over there, I don't.
He has all this marker boards.
I need to leave all that stuff out there, because that's all the formulas I need after the next.
You've got some over there.
What if someone came in and
The
for a prank
walls.
they erased all of your marker boards?
Then you don't get any formulas, so.
What if it wasn't us?
What if it was
Doesn't
the
matter.
second
We should
grader?
do it after our class so that the ninth
What if
grade
it was
pre-calc
your
gets
kid?
none of the formulas.
Never gets kid here.
We're gonna
Alright.
release 7th,
Has it on
6th
my
graders.
bucket list of results.
If I found it to you guys, you wouldn't pass.
What do you mean
So,
we wouldn't?
alright,
Okay,
there you go.
I'm not
This
gonna
isn't
do
our
it, it was
stuff.
just a question, but if someone does it,
Hey,
I'm scared.
Foiling it out, or let's simplify this so it's a little bit better looking, because I can actually factor this apart really
Senior
quick,
prank.
because I noticed that they have a couple things in common. I'm gonna move the 2x out front with the 2, so it makes 4x.
Sad.
We have an x
You can just do
squared
that.
plus 1,
You can't.
and we have
do
1
that.
minus x squared.
Jamie.
Wait, you can actually
Sure,
do that though?
Mr. Wood.
I can rearrange, because those are all being multiplied in the back, so I can rearrange.
With
Are you not just gonna have to multiply all in the
Just
end?
look at it.
Anyway?
Yeah, but if you notice the back,
Jamie.
alright, the back actually has an x squared plus 1 in common, so I can actually factor that out and put it out front, and then I can figure out the critical points of that, or the inflection points, sorry, because we're doing second derivative, so that's inflection points. So to do that inflection, we have to factor that back part out, and here's why I would actually factor instead of multiplying everything out, is because on the top, if you notice, there's x squared plus 1s, everything has it. Let's stop, seriously.
I can't.
Then go, leave. Alright, so,
Leave it alone, chill.
so the x squared plus 1, I'm factoring that out because both things on the top actually have
And
it.
negative 2x.
And so I'd be left with a negative 2x.
What do you do
And-
with the
Why
square?
can't you just pull out a negative 2x out of both then?
To write.
Because they both have a negative 2x.
Yeah, we'll pull out negative 2x.
Thank you.
Okay, we'll pull out negative 2x, so this is gone.
Oh,
So-
good.
So right here, we're missing one of these, and the negative 2x is gone. So that went out front, boom. And here, I'm left with one of these, this is this first part, minus, but that'll actually turn out to be a plus because it divided the negative 2 out. That'll be a 2 left over,
and then
and then the 1 minus x squared.
That was one of mine.
I
Yep,
thought we were
And that's
supposed to
all the
find
brackets.
yep, we are.
Are you?
Find a second derivative
Alright.
to do that though.
And at this part, these can cancel, like, so I can make this a 3, because one of those would go away. And so what I'm left with is this part, and I can simplify that. And I have the negative 2x out front, so figuring out the inflection point.
Wait, yeah, if you have another one, can you not do that?
No, because it's being added.
Alright, so what we have here is we have the 2x. In the middle here, I'm going to simplify this. This turns out to be a 2 minus 2x squared. And this is an x squared plus 1.
Wait, wouldn't you just?
So this will turn out to be a 3 minus x squared. What?
Why can't you just like say like 1 and 1?
I'm
What?
saying, why did you distribute it, I think?
Yeah.
Why did I distribute this 2?
Yeah.
Because it's.
Oh, yeah, because if you plug in 0, never mind. I don't know, I'm being dumb.
Alright, x squared plus 1, there's 3 of these on the bottom, that will never turn out to be a 0 down there because you're squaring it.
Why are you using brackets on top? Is there any reason for that?
No, because I had the brackets earlier, so I left them. Alright, so that was the part in the bracket, this is the part on the outside, and what makes this 0, you'd have to solve this thing out and this thing. So there's actually 3 inflection points. It could be 0, that would be one of them.
Positive or
And
negative?
whatever makes this thing 0, which this thing factors apart to be,
Positive, negative, square root of 3.
which would be,
X
square root
plus
of 3 plus x, square root of 3 minus x. And those would be the other 2 inflection points. So it would be negative root 3 and positive root 3. Those would be your 2, so we have 3 actual options here. Now, again, that would be like the maximum limit of difficulty I'd put. Because again, that is tough. I'll probably just put problems that you can easily factor. The problems I give you will be factorable, or they'll be at a point where you can do the quadratic formula to it, you can figure out the other 2.
Right.
Okay, this is just, the second derivative was difficult, but the actual answers are not. Alright, we're good with number 6.
Yeah, the numbers are critical points.
Critical points we, or 1 and negative 1 that you found earlier.
Where?
First derivative.
And then first derivative.
We factor the top part.
This.
Right, and so
Is
does
this all down here?
yeah, and then if you oh, here, wait,
That's interesting question.
that's the end thing.
Well, this must be going to 1.
Well, I got this.
Okay, I got it.
Actually?
I'll make it easier, it's not gonna be super difficult, because I gotta get you done in one class period, so I'm not gonna put something that you can't do.
Yeah, this is gonna be a long time. I don't know how you're gonna make this.
That's like pushing the limit right there.
I don't know how you're gonna make this a one period thing.
You'll be fine.
You can make it a lot easier than like that. That's a long one.
Okay, we're good? Alright, I'm erasing, we're moving on.
How about don't do any fractions?
No, I'm
We kind of bracket.
Those
Draw
take me
Absolutely
forever.
no fractions.
What'd you
Mr.
say?
Warren.
Those take me forever to do though.
Okay,
Let's just
alright,
let it-
here we go. 7.
Yeah.
Every time in a fraction on this test, we get an extra.
Alright,
Alright.
alright. Indicates the graph of the function. Now, this thing is the first derivative graph.
So where it hits 0 is inflection point.
Perfect, thank you for
Why
explaining.
do you-
Alright,
Thank you
So,
for saying that.
no, because it's just one of those things, you just have to see it. You would not believe how many people would pick the hills and valleys.
Okay.
It's the first derivative, so you just pick where it would hit 0. So these are the inflection points, right?
Oh, yeah.
Okay, that's, because it's the first derivative. If it was a normal like function graph, like the original graph, yeah, you pick the hills and valleys. But since this is the first derivative, what makes it 0 is the inflection point.
No, you see that, that says critical.
No,
Yeah,
it's like,
those are critical points. It's what makes it 0. Did I say
What?
inflection?
You
What I
You
said?
said
Oh, I
inflection?
I meant critical, sorry.
I
critical.
just
That
wrote
makes
inflection
sense.
on my paper.
Alright, so critical points are what makes it, 0 for the first derivative. So you're absolutely right. Now, one of these we throw out.
what did you just say?
The critical points are where the first derivative is 0. Where the first
I
derivative is
definitely said the
0.
opposite thing because I thought it was concave up and concave down.
You're thinking of second derivative.
You're right, you're right.
Okay. Alright. So what we have is we have 3 points of critical points. One of these is thrown out. Okay?
Why?
One of them is thrown out. This one right here is thrown out.
Because it's an inflection point.
I gotta go.
Because you're kind of right in that respect,
So
because
long.
you're actually explaining. The reason why is that it didn't go from negative to positive or positive to negative. It bounced off of the x-axis. It doesn't count when it bounces.
What is it?
Because what this is actually explaining, do you agree that these numbers are positive?
Yep.
These numbers are negative.
Yeah.
Oh, yeah, it's critical.
Okay, what that is, that's a maximum at that spot on the original graph. Because it went from positive slope to 0 slope to negative at this spot. So that's a hilltop. That's literally a maximum at that critical point. Because these were positive numbers for the first derivative. That was 0. These were negative numbers for the first derivative. So on the original
right
function,
before.
it's a hilltop.
So that's the
Or a
global
no,
or?
That's the critical point. So this would be a
It's
max.
a global.
Yeah, global or local? Or
I would say
Try saying that.
I'd say
How are you determining
Yeah,
global
what's
or
the
local?
difference?
I'm just gonna write max and you're gonna like it.
yeah, I'd just say max. Technically, I'm not really looking for globals. I'm just looking for locals and stuff on this
So
one.
pretty much just want to circle the point and write if it's max.
Yeah.
Yes.
How do
Okay.
we know that?
What? For, how do we know it's a max?
Because it went from
Positive.
positive
It
to
went from
negative.
positive slope to 0
Okay.
to negative slope. So it went from positive slope.
Earlier you were
Zero
saying,
to negative.
okay. and-
Like earlier he was like, I got this, and then else he's like, wait,
Alright.
how do I do that?
Now, this second point went from negative
Negative
slope
to positive.
to positive. So it went from negative slope
Seen that
to
problem.
positive slope and hit 0.
Neither of us.
This is a minimum. That's this one. This is a minimum on the original graph.
That last one was kind of like a.
And yeah, and so, yeah, you're absolutely right. This next one, and if you didn't hear Tyler, he's absolutely right. This one went from positive slope to positive slope. It never actually dipped to
Oh my
negative.
God, that's
So
what
he's
it
absolutely right.
is.
It did one of these things.
Oh my God.
That's not a critical point. That's not a critical point. It's just, it's a point where it just inflected a little bit. That's all it did.
So do we need to point out inflection?
No, on this, I just want to know max and min,
Okay.
and what were the actual critical points. We threw out the last one. Okay,
Oh, good.
does that make sense?
Is it
Yeah.
done now?
That's the
Yeah.
type of picture I'm gonna
Those are
give to
so
you.
easy, that's
Now,
easy.
I made that problem different because on the homework, it was giving you all those weird table things where it was like,
Oh, yeah.
yeah, I just gave you a picture of it.
Good.
That's what I'm gonna stick with.
I don't know what we're talking about, table thing.
I do. Give you
What about those lines and
Maybe
those
to do
dashes on it, that stuff?
I
Yeah.
remember
The
that.
three different lines that were like
Yeah,
first derivative,
yeah.
second derivative.
Yeah, it was that, and then there was the other ones where they had like, the first derivative, these are the points where
Oh,
these
God, I
were
hate
zeros,
those
these
so
were the
much.
second derivative.
I
It
know
was,
what you're
it was
talking about,
explaining
but-
this, but no one could figure it out. So I'm like, I'm just avoiding that.
How many more
So-
are we doing? Are we doing the rest?
We're doing the rest of it
No,
because
no,
the
no.
test is tomorrow.
Oh,
Yeah.
God. I'm so
Oh, this is the weird.
And then what we'll do is whatever we don't finish today for like the semester, we just do on Monday, Tuesday, and Wednesday. So, because we have 3 days for the semester.
Wait, so we don't have to take it on the chapter test?
No, chapter test is tomorrow.
No, I know we
The
do.
semester test, like, because today we're gonna finish this, but we may not have a lot of time for the semester practice, guys. So whatever we do, we'll just
We're not gonna have any time for this.
we'll finish it.
I will.
Yeah. Go ahead. Round what?
We have 3 problems.
3. Fine.
Three,
Wait 10
fine.
minutes and you take 10 minutes.
Just not take this
Oh,
semester
that's-
test if you want.
Okay. Global max and min. All right.
Yeah, same.
He's like, exactly.
Wow.
Don't you have to,
Mr. Ward, how do you say my last
Wow,
name?
then
that
plug
came
it all
touching
in
right
there.
got to you.
Mr. Ward. Yeah, Mr. Ward.
It taught you
Say
some
my last name.
words.
It's exactly like
Do you
David.
wanna
Okay.
go?
So, first, number 8. It's the easiest thing in the world. Find the first derivative. Figure out the critical points. That's pretty much what you do. If I want to know the max and mins, like this one's asking for, you plug them back in to the function and you see what the values were. Does that make sense?
Yeah.
So let's say, I'm going to make this up. Hope I'm not messing it up anyway. You're going to find the first derivative. Okay? And you're going to go factor it apart and figure out all those pieces. And again, I'm making up these numbers. Let's say my maximum was -2 and 3. For some point, I'm making those up. Let's say that those were the
Wait,
critical
what if there's
points.
only one? No, wait, there's two. Never
Okay,
mind.
let's say that those are my critical points. If they're not, don't write that down. But if they are, I would plug these numbers into the original function to see like what the numbers would come out on a calculator. That will tell me if it's a max or min. And I would also plug the end caps. The end caps. Now one of them was already covered. The 3 wasn't. It was covered. It was like, that was one of my endpoints. So I would plug these in and actually see now, one of these numbers I can throw out, right?
Wait.
On my critical
We
point.
just do, we plug the zeros of the derivative
Yeah, you plug
into
the zeros into here and you plug the end caps. If one of the end caps, like this one, doesn't count, you don't use it. Like right now, I can't use the -2 if that was one of them, because it's outside my boundary.
What?
You're right, 0.
How would it be -2?
I'm making those numbers up.
Oh.
Remember, I made these numbers up. I'm trying to show
If
you
it
what
goes
you need
outside
to
the
do.
bounds, we don't plug it in because it's outside of the bounds.
Exactly. You can only use the numbers in bounds. So you might only have one critical point that you can actually use. You might have 2, but you have to plug in the end caps, those numbers, figure out the maximum, which numbers are the maximum.
Or this confusing. Because like I have everything solved out. Here, so.
Just ignore those.
No, negative
I'm
1
just
would be
saying, like,
18.
what happens if you have 2 sets of the
Because
same
1 minus 3
2 sets of the same?
Because I have like
plus
2 numbers
20.
equals
1 minus
16 and
3
2
is
is 20.
-2 plus 20.
Fine, just use 2 and 20. Or 16, 20. Just use those 2 numbers. Just one of each.
So there's no
We plug,
No, like how is there a global if there's 2 at the same level?
Those would be relatives. They
Oh, it'd be
wouldn't
negative
equal.
1
So
minus,
just
negative
one
1,
relative.
negative
So it's
2.
put
Yeah,
NA.
you're right, you're right.
There's neither.
Yeah, I mean,
So-
you're giving critical points, but they wouldn't be a global max. It's not the
So
highest.
there's only local max?
But since it's asking for a global max, and it only has local max, so just put NA. Is that the answer to this one?
Minus.
Do the next
Wait.
What are you, there's two, is it local if there's two?
Yeah,
Wait,
if there's two, it's a
So
local.
Tony's the local max.
So do I just write no
Because it's-
globals and show
It's
my
negative
work?
1 and 16 and 2 and 16, so that's the
They're
Yeah.
both 16.
local
So do
min.
we write,
Local min, yeah, there's no global min or max, so you just put.
Because they repeat
And
it.
There's
so
two
it's a
20s
lower.
and two
So you
60s.
just put NA.
Oh, and
There's
the
no
But you
global.
better show me why it would be that. You can't just write it.
Wait, what?
It's adequate.
Yeah.
I thought there was.
I'm just writing local
we
max, local
don't, we
min.
don't have to write
This is the-
local, we just have to write NA.
Yes.
This is the only stuff I actually
What
remember.
if I write local, is that wrong?
You've explained why it's not global.
Okay, let's go.
All right. Perimeter of the rectangle is 64. So if I have a rectangle and I have x and x and y and y, and the perimeter is 64, here's what we have. We have to solve for one of the letters, so we'll solve for y. And that's how I solve for y. I divide both numbers by 2. Fine, dandy. All right, so there's my y number. All right, and it wants to know what is the length of the sides of the rectangle that maximizes area. To find area, I'm going to change my dimensions to be this. Does that make sense? I substitute out the y, I got back to one letter. I multiply them together, and then I take the first derivative of it.
Why isn't it? Oh, you already divided by the.
This is how I find area. I take x times the 32 minus x to get, 32x minus x squared.
And you find the derivative.
And then we find the first derivative, and wherever the critical points are, that would be the maximum number you'd want.
Wait, why are you putting the X out there?
What do you mean? I'm multiplying the dimensions, length and width. I have to get it back to one letter. I can't use two.
Oh, I see what you did. You made
So,
another
wait.
rectangle.
So then we solve for 0?
Yep, solve for 0. After you find the first derivative, you solve for 0 for each of them. You find your critical points. The critical points would either tell you the max or min. There should be usually one of them. There should be one number. And that would be like the x dimension that you'd want.
Did you guys say 16?
Yes.
I'm so.
So-
Wait, so that means number 16.
So this would be 16.
And y is also
And then you
16.
plug 16 here, and that'd be your other dimension.
So it's a square.
You can say
I
yes.
don't know what to do after what you've all done.
Take the derivative.
The first derivative.
Wait, is that how
The bottom
Yep.
one?
And then find the critical points that we've done on all these.
What?
So this is my function.
I know how to do
It's
this.
scary.
Set that equal to
Find
0.
the first derivative.
Mr. Ward, this is the first time I've felt like.
You
32
find
minus
the first
2x.
derivative. Is that the first?
I'm picking something like this. I'm not gonna pick something.
What about number 10? Basically the same thing.
Almost the same thing, but now we're doing
negative
a
x.
cylinder now.
So it would be
Solve.
What do you say?
pi
That's
squared
that's the one where this, hey, number 10,
16 minus X.
hey, number 10,
First derivative.
yep, number 10 has to be,
And then set the
it's
first
gonna be an
derivative
implicit
equal to
differentiation
0.
problem, where you have two variables, and when you take the derivative, you'll have to put a dy, dx kind of a thing in
I
there.
no longer click
And
on
then
it.
you solve for 0.
Because they're actually talking about,
Yeah, after the first derivative. solve for
increasing in
0.
depth, and one of the numbers is constant, so.
So we have to disrespect y.
What are you talking about?
Alright,
Then you factor the first.
okay, we good with that one? Can I go on?
And then
Yeah.
you
Alright, I need to take 5 minutes to do this next one.
Just
That's a lot of time.
know what you're doing, bud.
You should just like
You
speed
just
through
get
it.
the 32 minus 2X.
Okay. 32 minus 2x, yes. And
Yeah?
then solve for x. You add 2 over, 2x
Oh,
over,
that's just like 6.
and then divide by 2. X
Okay,
equals
so-
16.
Oh, that's not easy. I tried going into whatever.
You
it
just
is.
set equal to 0?
16 is
Vertical cylinder tank.
Yeah.
Has a radius of 3 feet.
I hate this.
Okay, 3 feet.
Okay.
When the gas is a depth of 4 feet, so here's my gas. Here's 4 feet. All right, 4 feet of gas is in the tank. The idea is that, and the depth is increasing, so we're going
Who's
up.
phone?
So we're filling this thing up, right? We're filling the gas tank up.
Yeah.
That it's increasing by 0.2 feet per second, so it's going up quite quick. And the idea is how fast is the volume changing at that instant? Like how fast is it changing right when this thing hit 4 feet? Like, what is the instant rate of change at that moment? So that means you gotta find the formula for my cylinder. It's up there. Take the first derivative of it, and then plug in my values that they gave me.
Where's the
So-
cylinder?
My cylinder's up there, so we're doing the volume, right? So volume.
Where's S?
So-
I do anyway.
It's going.
Okay.
Yeah, it does.
So, can somebody give me the volume of my cylinder?
Pi r squared times h.
Pi 3
Pi r squared times h. Alright, so pi is a number, r and h are numbers.
We don't have H.
Okay, we don't have h,
So we have to go
so
for H.
but the idea is that we do have the height at some point that we will be plugging in for the height at some point, okay? And the depth is increasing, right? And it wants to know how the volume is changing at that moment. Okay, so when we take the derivative, my radius of my tank, do you agree that the radius is not changing?
Right.
Right.
So that one is just a number, it's a
3.
digit. So we're gonna be plugging that in, okay? So, on this case, yeah, we'll be plugging in this moment, we'll be plugging the 3 into that spot. So pi, we'll be doing
Can we just do
3
9 pi?
squared.
We just write pi 9.
9 pi.
Yeah, that's fine.
Please,
What?
God.
Alright, we're plugging 3 for my radius,
okay,
right? Because
okay.
it's a number. The radius is not changing over my whole problem. But we have to figure out the derivative. Now,
I hate that so much.
okay,
Also write pi 9.
is there any questions with what we're doing there?
No.
Okay, so what we need to do here is we're going to take the derivative of this thing. So the derivative of v is dv dx, or dh I should say. We're taking it with respect to h. Because h is the one
No,
thing
it's
we're...
always x. You have to respect.
Yeah, we're respecting h in this case. Okay.
All
Alright.
Am I wrong if I put D?
And the idea is that, in
Right.
this case, we have the
Do you
9
respect
sitting here.
your X?
And the derivative of h is 1 times d dh.
I would check it out.
That's one of those kind of joke.
Did that hurt his feelings?
Alright, questions at all about that?
Can you
Okay,
get
now,
one and just put-
I'll explain something here for the most part. 'Cause there's always a question I always get on this problem is that, Ward, why didn't you take the derivative of the original thing with r? Okay, because r wasn't changing, right? R was staying the same.
Wait,
So if
we're
you were to
taking-
take, and we'll be plugging in the
D
d
over
dh
H.
here.
Where did that one come from? The H.
That's the derivative of h.
Why did we do the derivative of the other thing?
The pi.
Because it's a 0.
It's a different.
Why didn't we just put 0 then?
What?
The derivative of pi
Yeah, he said
9 is 0.
Yeah, but we're just doing, these are numbers. When you take the derivative of something that's just numbers, you ignore it. So,
No, you put 0.
no, when it's like, if it's 3x, you take the derivative of 3x.
3.
3. You ignored that number. You didn't say 0
What?
because of the 3.
Do you accept the mirror? You look at right 16, right 16.
But we're saying like if you take the derivative of
Right 16. Yeah,
you
take
get
the
0.
derivative
No,
of
actually,
16.
let's
That's all one number.
Right, that's
It's
what
all
we're getting.
one
We're like,
It's way enough.
the derivative of 3 is 0. Is what we're trying to-
Oh!
This is a number
You
in front
right.
of h.
You right,
So it's
you
just a
right.
number h. So the derivative
Oh
of
my
h.
god, you're so right about that.
Okay.
Yeah.
I like how
I
you're
was like
staring us
losing my
down.
mind.
The rain.
Now, how's the depth increasing by?
0.2 feet per second.
Okay, 0.2. So the depth here, the
Huh?
height is changing. So the height is changing
So it's
by
only D over D?
by 0.2
Yeah, why?
feet per second.
What happened to our
Why'd you do the V?
Times
Why'd you
1
delete the V?
times
Delete the
9
V.
times pi. And what this is the actual rate of change at the moment where your height is 4.
Why'd you delete that one? Why is it
So
D
you
over
made it the
D?
derivative.
The derivative of h is 1, but then we don't know what h is, so we just put a ddh by it.
Oh.
Wait, so that's your final answer?
Yeah.
I don't even
That's a
know
good
what to do.
Well, Ward, I'll see you tomorrow
Right.
morning.
I'm gonna stay in here and write this down.
1.8 pi!
I may be
This
here
was on the
with you.
homework.
He gets all the homework.
Crazy how that works.
Have you not
I think I don't do that.
for 3 years? That's why if you
Pi
actually do
times
your
9
homework, you
times-
do way better on the
So is
test.
it just
That's why I
feed
suck
them
at the
as the
test.
answer?
For a second.
Wait, can we just leave it like this
We're
though?
doing everything to what I was
You
saying.
multiply.
Don't let our secret out.
I just turned into what works.
Sure, I didn't do any of this.
I figured I should have done that. Oh!
I was thinking about it at the start, I was like, wow, that purpose.
just sit there. So,
I know.
you,
Yeah, Ward, math for. Hey.
But hey, it's good to see you.
Pen.